Hey folks, I'm Chuck Black. We're doing 52 weeks of Python and we are in week number 43. We're talking about databases and we're in the second lesson on databases. And in this lesson, what we're going to talk about is how we go from what we had before with this Flask server. I called it the mini-quokka server that had global dictionaries for storing host devices and services, a bad idea, and moved the data where it ought to be, which is in a database. So we're using SQL to do this. First of all, that's what this lesson is about. The output for this with the databases looks pretty much like this. The server that's running is doing its gets and puts, and over here on the left you can see that the monitors for host services and devices is running happily as well. We spend most of the time in the code. We'll be comparing where we were. I'm looking here at the old code in the Flask mini-quokka where we use these global dictionaries, and we're moving that to use SQL type data. So we're defining classes, we're creating them, we're creating at the API layer that will help our endpoint functionality here to just call get all hosts, and that will work whether we're using SQLalchemy or MongoDB or whatever it might be. So we're going to go through all of that code. Hopefully it will be interesting to you and you'll get a lot out of it. So yeah, let's get started without further ado. Okay, so let's talk about moving our mini-quokka type thing that does service and device and host monitoring from using in-memory storage, just in the form of Python dictionaries, into using a database. So what we're looking at here, all the stuff going on in the background, is actually the implementation of the code that I wrote that actually does this. So it's actually going to a database to present, to get the data to present, and it is actually writing the stuff using the same mechanism as before. So just so that I can show you, here's the mini-quokka server that's running. You can see a bunch of gets and puts going on constantly. So that's running as my Flask application. There is a script that I created that runs all of the monitoring applications. So it's running service monitoring, and it's running host monitoring, and it's running device monitoring. So you see this, the device stuff going on and the host stuff going on, etc. So that is running at the same time. In terms of the display, this is my services display. You can see that it's updating in the light green. You can see the time that has been updated to show when it was last heard from. I'm printing these out in whatever this color is, cyan, I think, because it's not meeting the service level agreement. I think the service level agreement is half a second for that, and for my ICMP gateway it's 1 second, so that periodically comes and goes. This one down here, this Ubuntu Quokka, also I think is set at 1 second, so that comes and goes as well. Up the NTP one failed, and yeah, so you can see that it turns red if it's not available. That is the service. Here's my host display. So this is getting the host information for hosts that have been discovered and hosts that are constantly being monitored. You see the light green ones are the ones that have just been updated. You can see their time is a little bit newer or more recent. Now you can see that that's true for these down here. It's red if I can't contact it, and that is all that I do here. I show the MAC IP availability and last heard. I'm not printing out the response time there. And then this one is showing the device information. So you can see I have these two Cisco sandbox devices that I'm going out and getting information from. I got their IP address. I'm retrieving facts, so I get their model number, I get the version. You'll see later that I actually have a version check. That's when we move to a Mongo database. It has nothing to do with the database, just some functionality I added. And I'm doing the response time, last heard, etc. So that is all happening with the database. So let's remind ourselves of what exactly we did before we start to dive into the code. Where we were was this. We had this Flask server that I'm calling the mini-quokka server, and it had these in-memory dictionaries that were holding information about host devices services. I have in the code stuff that says don't do this, it's a bad idea. in a Flask application because you can have multiple threads coming in trying to modify stuff at the same time. So we don't want to do that, and therefore we took their first opportunity once we'd implemented it to do something different, and that is using a database. So in this situation, I'm using an SQL database, and I have table for devices, a table for hosts, and a table for services. And my application is nice and short and sweet. It doesn't really do much except go out to these databases and either read them or write them, or sometimes both if necessary. So that's kind of where we got to. So let's now that we know the overview, let's look at the code that implements this. Okay, so let's get an overview of the code changes that took place. I'm looking at the Quokka server. This is my SQL version of the Quokka server. This is the old version, the one that we looked at a couple weeks ago where we implemented things in memory. And so let's look at the difference between the two. Now, in the old version, remember, we declared these global dictionaries that were going to hold our host information, device information, service information, along with a big comment and disclaimer that says, don't do that, please. Over here, in comparison to that, I have all of this stuff that you see right here. That's all setting up the database, and I am going to go through that once I've given you this overview. So just understand that there's a difference there. There's some initialization of the database and getting it created, etc. So let's look at a comparison between the two endpoints that are used to serve the requests that come in to the host's endpoint. So I have functions over here on the left is my SQL version. Over here on the right is my using global data function. Now, one thing I want to point out right away, over here on the right, this is what we did a couple weeks ago. You'll remember I handled post and I handled delete a couple times ago, even though I never use those endpoints. So in order to make this comparison a little bit clearer, I got rid of them just from this particular piece of code. You can see I left it down here. It doesn't matter if it's there or not. I just want to make it easier for you to compare and contrast the two next to each other. So let's look at what's going on. The first thing you'll notice is I have this reference to the global host. I don't need that over here. I'm going to be using the database. Now let's look at the get method. If the method is get, then I'm going to return global host. That's my global dictionary. That's pretty easy and straightforward. That's why we did it. Now over here, it's almost exactly the same, except I'm calling this function. I'm calling a function called getAllHosts. And what is that going to return? Well, as you imagine, it's going to return a dictionary of the hosts, but it is going to return it from the database. Now, there's an important thing I want you to realize here. I'm calling this function called getAllHosts. And if I look here, getAllHosts is located in this module that I've created called DB APIs. I've created this because I want to be able to use exactly the same code that you see here, no matter what database I'm using. So I want to be able to call getAllHosts from here so that this code that handles the host's requests doesn't have to be aware or knowledgeable about the details and the nitty-gritty of the actual database implementation. All it has to do is call getAllHosts, and we've sort of contractually agreed that getAllHosts is going to return what I need. Now I'm going to just poke my eye down into here, and you can see getAllHosts. Well, this is doing actual SQL type stuff in order to get that information out of the database. That's okay. getAllHosts itself is completely database. Actually, it's data agnostic. It doesn't care where the data comes from. It just knows that it's going to return this dictionary that's going to look like this, and it's going to have hosts, and it's going to have the first thing will be this host name. And so that's what that does for us. So when I go back here, whether I'm doing Mongo or SQL, I actually could have implemented this particular function in the same way, and this code does not have to change. That's how we want to write software. Could I have put everything in this one application so that it's all has every single detail about the database, about everything else in this same module. Yes, I could have put it all in the same module, but that would have been bad programming practice. So I want you to begin to develop some of these habits that will make you more than just a script writer or a copy and paster, but an actual software developer. So these look pretty similar. If method equals get, then get all hosts, and in this, all I'm doing is returning the dictionary directly. In this situation, if it's a put, let's look at this code. Well, it's a little bit longer than the previous one, than the get, but looking at it and examining it, it's pretty much the same what the two things do. I'm going to try to get them lined up here a little bit closer. It gets the host name. It returns an error if it doesn't have the host name. It gets the JSON data, and over here it gets the JSON data. And the only difference is I'm going to set my dictionary here equal to this host. In this situation, I'm calling set host. Guess where that's located? Well, you wouldn't be surprised if you know that it's also located in our DB APIs. And if I go and drill down into it, we're going to look at this a little bit later, but this is the code that's going to actually do it, and we will go through that. So that's a high-level overview of the difference between these two things. If I go down to the bottom, they're exactly the same. You'll notice I didn't get rid of post and delete for these other ones, but they're fundamentally the same whether you are looking at this one or that one. The only difference is I'm using global data over here and these local in-memory dictionaries, and over here I've got some databasey stuff going on, and that's what we're going to discuss next. All right, so let's begin to dig a little bit deeper into this code. Before we look at the code itself, let's look at the code that is in this package, this one that we're working with, M07B Flask SQLalchemy. Now you look in here and you initially would say to yourself, whoa, that's a whole lot of files. Am I going to have to learn all of that stuff in order to do databases? Well, hang on just a second. Let's look back here at our Flask quokka where we immigrated from, or where we migrated from, I guess you'd say. That also has many of these files: device display and monitor, host display and monitor, service display and monitor, service monitor, services, devices.yaml, stop monitor, run monitor, etc. Let's look now down here. Look at all the ones that are the same. This one here is new. This one here is new. Device display is the same. Device monitor is the same. Devices is the same. Extensions is new. It's a little quirky Python thing that we have to work around. Host display is the same. Host monitor is the same. We've begun to look at Quokka server. That's what we're going to look at next. That's new. Run monitor, all service display, service monitor, services, and stop monitor. Those are all the same. So the things that have changed, ignore the color coding right now because that means something different. APIs and classes and Quokka server, those are the main things that you have to be aware of. Quokka server is what we're going to look at right now. And then DB classes and DB APIs is what we're going to look at next. That's how we implement our interface to the database. So let's begin to dive down into the Quokka server. And the main thing, as you recall, is not this. I'm just calling my DB APIs. The main thing is all of this extra code right here. So what is this doing exactly? All right, so we're going to ignore this for a minute. It's a minor Python thing that you need to do in order to work around circular import issues in Python. If you want to get confused and find people complaining about Python stuff, look up circular imports, and it is something that ends up biting you on the behind quite regularly. So this is how we work around it here. We're not going to look at that right now. So let's just get started. Flask, passing in the name of the program, becomes my Quokka app. That's the same as we've done before, all right? Now, Quokka configuration, there's a couple things here. The first thing of interest is I'm pointing my Quokka application at the database. So the database that we're going to use is SQLite. The place that the file is located is this one right here. This is the one that they use in just about all the examples that you see. Make sure that you use the right number of slashes, / hash mark. That's not a hash mark. It's a / or stroke or whatever you call it in your dialect. But that thing right there you got to make sure you have the right number and just imitate it as you see it in the examples or in this code. This here is something to just get rid of some annoying warning messages. Now the next thing that I'm going to do is I'm going to say, so my DB, I'm importing it from extensions. We'll look at that in a second. I'm calling into that DB thing that I've imported, and I'm saying, okay, initialize it with my application, and this is the application, the one I just created. So this is going to actually do the initialization stuff of Flask and my SQLalchemy object that I will be using for communicating with my database. So this is just stuff that we end up calling, all right? This is a little bit cookie cutter. They have different versions of this. Be sure if you're going to do something like with Flask, then you got to make sure you probably use something similar to what I've done here in order to get rid of the circular import issue. The last thing we need to do, and this was something it took me a while to find, is we have to push that application context information. This is all Flask SQLalchemy stuff. So this is not me implementing something. This is just me telling Flask where the database is and getting SQLalchemy's Flask version that we're using able to communicate with that database. All right, so that is the setup of the database and associating it with my Flask application. Now the next thing that we're going to do is we're going to let SQLalchemy know about all of the tables that are going to be available in my database. And this is where I'm going to import all of my classes. So I'm going to say import DB classes. Let's poke our noses down there. We'll look at this in more detail in a little bit. Here is my DB classes, and guess what? So this is pretty much the same as what we saw before. I'm defining a class. My class is called device. Remember my object-oriented stuff I'm inheriting from db.model. And the fact that I have reference to DB allows me to create all of my columns. Now I have a bunch of columns. I'm basically mimicking what the real quokka, the actual one that I've implemented that is elsewhere. And that if you looked at the lesson, what was it, 40, I think, where I talked about use of Flask and quokka, you may have seen that a little bit. If you've gone through the quokka code walkthroughs, then you're familiar with it as well. This is how I set up all this information. So hang on a second. Why am I having to define all of this stuff? Well, do you remember in the last lesson when I talked about different types of databases? There's an SQL type of database and a NoSQL type of database. These guys over here on NoSQL are pretty much loosey-goosey. It's flexible. Sorry if you don't know that word, but it just means that it's flexible. You can have your tables have any columns that you want. You can add, effectively, I'm putting in air quotes columns because they're not really columns. They're defined by JSON data that you put in there, and everything you put in is a single document. Not so in our SQL world, okay? It is structured. Everything is predefined in terms of our schema, in terms of our tables, in terms of our columns, and we'll just be adding rows to it. Guess what I'm doing here? Here I'm defining my tables. Here I'm defining my columns. So this has to be done correctly, and it will effectively be, it won't necessarily last forever, but when you change your database structure to have different columns, etc., you need to do some form of migration, or you need to blow your database away and bring it up anew. So that is one of the downsides of having everything statically defined. But that's basically what we're doing here. All this predefined stuff, we're going to be doing this. When we get to talking about Mongo, you'll see we don't define any classes. Like I say, everything just happens magically and we create things on the fly. But in SQL world, everything is very regimented and structured, and you need to make sure that you do it correctly. As I say, we're not using a lot of these things, so don't worry about them. But many of them we are, maybe probably most of them. Certainly for a host like here, I think everything that you see here we're actually using with respect to the host. And with respect to the service, we're using everything that is available here in the service as well. The reason that devices is so big is because in the real Quokka, I spend time trying to handle netconf and a bunch of other stuff that I'm not doing here. But these are my definitions. You'll notice that I give the table name, this underscore underscore table name. When you see things with underscores, it means that it's internal. When you see something that looks like this, like underscore underscore with both sides, that usually means that it's something special. And what this means is it tells SQLalchemy that the name of my table in the database is going to be this thing right here. Now, some versions of SQL that we use will require this. SQLite, I believe, doesn't require it, but I put it here because I believe Postgres does require it, and that's what I use in Quokka. So this is my definition of all of the columns. I have an identifier, I have a host name, I have an IP address, MAC address. I'm going to be storing the availability and the response time, and of course I'll be storing the last heard as well. And when I create it, of course, I'll be putting in the host name and the IP address and the MAC address if I have it. I actually think that I don't use ID with the host at this point in time for my little application, but these were taken directly from the Quokka application. So this is where I define my tables, all right? So that is what I'm doing when I tell my application here, my Flask application that has SQLalchemy running with it, that these are my classes. That's why I do the import. And then remember, as I mentioned before, create all. Basically, if the table doesn't exist, it will create it with all of the appropriate columns. If the table does exist, then it will only need to set up the linkage between my application and that database so that I can do stuff with it. Now, the last thing to look at here is I'm actually going to be using these. These are all the things that I actually define myself for getting data and setting data. So get hosts, set hosts. For hosts, I'm going to have get all devices and set devices, get all services, set services. So those are the things that you see down here in the rest of the code. This is where I'm going to call into my DB APIs. And now that you know how the database is set up, and we've looked at the classes that are being defined, those would be the tables. Now, next we can look at the APIs. So let's dig into these DB APIs. Now you'll recall the purpose of these APIs is so that my code here can just call this API and it doesn't have to worry about any of the back-end database stuff. It could be SQLalchemy database, it could be a PyMongo database, it could do Redis. I actually thought maybe I should be doing Redis. If you are interested in learning about Redis, shoot me a comment either on YouTube or Twitter or wherever, Discord, wherever you contact me, and let me know that you would like me to do one of these for Redis as well, and I will do that. But for right now, just understand this is an API that allows my code here not to have any knowledge of the nitty-gritty of dealing with the database. So let's look at the DB APIs and see what they look like. And as you might expect, they're going to look pretty much the same whether it is for hosts. Here's my stuff for hosts. Here's my stuff for services. And you can see that it's pretty much the same and the same for devices, except there's different information in here. So let's look at hosts. That'll be the easiest and the simplest one. So let's do get all hosts first. Now what's going to happen, if you recall from our last lesson, is I'm going to query the database using the host table, passing in this host as an indication that I want you to do a query from the host table. And what I want you to give me back is everything from the host table. So I'm not limiting it, I'm not filtering it, I'm not ordering it, I'm just saying, just give it all to me, all right? So I'm using DB, which I've imported from DB classes, and I am calling into this session. Remember, session is the thing that is going to be unique for my Flask application, and it allows me to have an individual session for querying the database. It allows there to be concurrency, etc. You don't have to worry about it. you just can follow this pattern. So I'm doing db.session.query, and I'm saying my query is to the host table, and I want you to get me all of them. Now, all I need to do then is return all the hosts to the caller, because my caller, remember, is just doing get all hosts, and he's going to return this nice Python dictionary. But guess what? What I get back is a list of host objects. So that's good. It's gotten me all the data from the database. I didn't have to construct an SQL query. I didn't have to do anything. It's all in Python format, but I want it to be in a simplified version where I actually have the same exact structure as I had before. And so what I'm going to do is this. Now, if you look at this and you've been following along in the lessons, then you probably can figure out, okay, I see I've got curly braces. That means there's probably some dictionary stuff going on. There's a for loop inside it. Okay, well, that's probably an indication that there is a dictionary comprehension going on. So what's going to happen is I'm going to go through this list. It's a dictionary comprehension, and I'm starting with a list. And so this list is going to go through, this code is going to go through the host objects list. And for every host object in there, it's going to create an item in the this dictionary that it's creating. And the item that it is going to be creating is going to have as the key the actual host name, and as the value, it's going to be the host object, all right? So let me just go through that again, because I'm not sure I made this clear enough. A dictionary comprehension, I'm going through this list, this host objects that I just got is a list. I'm going to go through that for every item in there, which is basically an object representing the host. I'm going to create a dictionary item. The key is going to be hostObject.hostname. Remember, because host is an object, I'm going to say dot whatever that is. And in my class definition, if I go to hosts, let me scroll down here to host, you'll notice that there is something called a host name. So that's how I'm referring to that. The key is the hostObject.hostname. The value is going to be host object, but I need this value to be a dictionary. So I've written a function called getAsDictionary, and all this is going to do is it's going to go through my my items in the model object that I am passing in. And the first thing that it's going to do, remember this is a dictionary comprehension as well, it's going to go through here. Here's my for loop. This is the way you go through a for loop in a dictionary. Let's focus on the things we understand. So when we go through a for loop and we are dealing with a dictionary, then what we need to do is dot items, all right? So dot items takes a dictionary thing and gives me an iterable that I can go through it in a for loop, all right? If I'm doing a for loop, then and it's a dictionary, I need to do dot items. Now, this __dict__ gets this model object as a dictionary. Now, that's great. It gives me the model object as a dictionary. That's really all that I need, except for one fact, and that is that there is internal data in there, internal data that starts with an underscore, and I want to make sure that I remove that. So if the item that it's going through, if the key that it's going through actually starts with an underscore, then I am going to ignore it. So the end result of this is just what this explains. It takes model object and returns a dictionary, but what it does in the dictionary is it's actually extracting and removing anything that starts with an underscore. So that's all that this is. And I would say, if you're newish and this is kind of confusing for you, then don't worry about it. Just take my advice. This is what it does. And as you become more familiar with things like dictionary comprehensions, dealing with objects and translating them into dictionaries, iterating through them, taking a string and saying starts with, once you become more familiar with, you'll become more familiar with. But just understand, okay, this is exactly what this is going to be returning. So it's going to be returning these hosts. So let's go back to my caller. So this will be all of the hosts that were in the database. Let's go back to my caller, and from this method, I'm going to be returning get all hosts. I'm going to be returning all of the hosts. Now let's look at what we're doing when we are actually setting a host. So this is going to, in a certain sense, be a little bit easier. So let's go down here, even though there's more code. So I'm going to do a set host, and I'm passing in a host. Now the first thing that we need to do is we need to get the host object from the database. So what I'm going to do is I'm going to get the existing host from the database. And so let's look at this query. What I want to show you, I'm going to explain this query to you first, and then we'll look at this stuff that's grayed out here. My query to the database is going to be, it's going to be similar to this one. Here I did db.session.query parentheses host. I'm doing the same thing. This time I'm going to say I want you to filter it by, and I'm passing in the thing I want it to be filtered by. And the thing I want it to be filtered by is the host name, and the value that I'm passing in for that keyword is going to be the host name that got passed into me. And now here in this situation, I'm getting either one or none. So I'm going to get the one that exists, or I'm going to have returned to me a none. In other situations, if I tried to get one of these, then I can end up in situations where it throws an exception and I have to trap it. So in this situation, if it doesn't exist, I want to make sure that it just gives me none. Now, what I want to point out here is this thing right here, and I talked about this in the last lesson, and hopefully you were paying attention. Remember, we had something that looked like this with a star, and then a value? Let's look at what this code here does, and you will see that *search is going to be exactly the same as hostname equals host subhostname, host with the key of hostname. In this situation, I actually did these originally, and let's see, I changed all of them. I did them originally as I've typically done them, which is if you're doing a more complicated search, then you create a dictionary that actually has multiple of these in there. In this situation, this dictionary only has one key and one value, so it's pretty straightforward. When we would execute this line, when Python would execute this line, when it created the keyword arguments out of search, this dictionary, it would take the first item and use that as the key. That's exactly what I did manually here, and use the second item and use that as the value that gets passed in. So I left this here so that you would, in case you were a little bit confused by what we went over last week with this * and then the thing that we were looking for, I think it was device. In this situation, this is exactly what it does. It takes a dictionary, and for every item in the dictionary, it takes the key and it uses it as the key name right here, and then it takes the value and it uses that as the actual value that we'll be searching for. And if you have multiple of these, you can also do it by hand here, or you can use a search dictionary and it will change. If you have 5 different things that are criteria for the filter by, then it will do it with the 5 different items down here when you do * search. Now we're going to either find the object or we won't. If we don't find it, then all we need to do is we need to create a host object, and then we do an add. All right, so let's look at this. This is because I talked about this before. Host is my class that I defined. Remember, in classes, it's this thing right here. So it's going to create a host object. And what is it going to pass in as parameters for creating it? It's going to pass in the host that was given to me. We're expecting it to be a dictionary. And again, these keyword arguments are going to get extrapolated or expanded to be something that looks like this with host name and IP address and MAC address and availability, etc. And this is all I need to do. This is for adding something that's new. If I'm updating this something that exists, then in a similar way to what we did in the last lesson, all I need to do is take host object, which is what I got back from the query, so I know it's not null, and I'm going to say .IP address equals this particular value. And what I'm doing here is I'm first checking to see that the host is passing it in. This host that I'm getting in may only have one thing to update, like it may only be updating last heard, or maybe just availability and response time and last heard. So if it's not passing these things in, it does not make any changes. If it is passing them in, then we set our host object. Remember, that's the thing we got from the database. We set that value to whatever it was. IP address, MAC address, availability, response time, last heard. And if you recall from our last lesson, we don't have to do an update. Over here, we had to do an add. Here, we don't do an update. We just do a db.session.commit. And SQLalchemy is smart enough to know, oh, this host row has changed, and therefore it needs to write that to the database. So the item will either be added, which is the case where we did this query and it was none, or it will be updated, in which case the host object was a legitimate value. We got it back, and so we're updating the IP address, MAC address, availability, etc. And we do a commit. And this is going to be the same for services as well as for devices. And that is the API. That's what makes it so nice, is that I have implemented get all hosts and set host, and get all devices, set device, and get all services and set service in such a way that this code right here will not have to change when it comes time for me to change the back-end database that I'm using. So of course this stuff up here will have to change when I move to a different back end, but the point is that the implementation of these endpoints, that is these functions here, will not need to change, because get all hosts, if it's implemented correctly for Mongo versus Redis or whatever back end we're using, it will return the data to us in a format that we are expecting. Okay, the last thing that I'm going to explain is this thing right here. I mentioned it before. I said we'd talk a little bit about it. I mentioned it has to do with circular imports issues in Python, and so that's what I'm going to explain right now. If this explanation is beyond you, I give you permission. You have a permission slip from me to ignore it, or to don't worry if you don't completely understand it. If you think you'll be working with Flask and SQLalchemy, you probably want to have a general idea about what's going on. I did run into this when I was implementing it a week or so ago, and had a few times of banging my head on the table trying to get it to work. Finally found something online that actually was a more advanced pattern for doing what I'm doing here. So I've simplified it to make it as easy and straightforward as possible. Yeah, that's kind of what the situation is. The idea is this. If we look in extensions, you can see here I'm creating my database. And I would normally create my database in here. And so that would have been okay. But the problem is that when I then create my database and I then create my classes are going to be pointing back to my Quokka server, and Quokka server is going to be pointing at the classes. Do you see what I mean? So my classes would have been pointing back to, instead of doing extensions, it would have been pointing to Quokka server if I had implemented it in that way that I was describing, and Quokka server would have been pointing to classes. And so you end up in this situation, and it's very annoying, and the errors are not clear exactly what's going on. So the recommendation is this: you create another file. The sole purpose of this file is to create your database. And now everybody that needs DB can point at extensions rather than pointing at each other. Before, we had Quokka server pointing at DB classes and DB classes pointing at Quokka server. Now everybody that needs DB can point at extensions, and everybody will be happy. So what happens in Quokka server? I import this DB, that means that this code is going to be executed. I'm going to do SQLalchemy. You'll notice I'm not passing in the Flask application, okay? That's important. So I'm creating an SQLalchemy, which is from Flask SQLalchemy, but I'm not giving it the name of my Flask application. How can we get that to work? Well, the way that we get it to work is here I have an empty SQLalchemy at this point. Now I create my Flask application, and now when I get down to this point, I'm going to call into my database. That's the thing with the empty SQLalchemy object, and I'm going to call this function called init application, and I'm passing in my Flask application. And what that's going to do, it's going to set up the linkage between this Flask application, and this database, which is the SQLalchemy that I created. Okay, the last thing that I need to do is I need to do this .appcontext.push. Basically, that is pushing the changes that I've made to the Flask application and making sure that its context and db.initApp are set up, and the DB is set up correctly based on this init app. So you don't have to understand exactly what it does. That's a detail for the implementers of Flask and Flask SQLalchemy, but that is what I did, and that's why we use extensions. So when we go down to DB classes, you can see I'm getting DB. I need DB because I'm going to reference all over the place here. Look at all the times I reference DB. I need DB. Before I was getting DB from Quokka server. Now I'm getting it from extensions. So this is where DB was initially defined, and now that is where I am importing it from. And then APIs is just, I believe, I just import it from DB classes. But everybody points up to this extensions for the origination of this DB thing. And that's how we get around circular imports in Python with Flask and Flask SQLalchemy. All right, so let's quickly review what we talked about in this lesson. We talked about how our Quokka server that we built and talked about in the previous lesson on Flask had global data, and that wasn't good, so we moved it into a database, or we want to move it into a database, and that's what we've done in this particular session. So we looked at the actual running applications, the displays, we looked at the actual Quokka server that's running, we looked at all of the monitoring apps that are doing it, and we looked at the data that was being returned to us and how we're printing it out, just to remind ourselves of what it was that was going on. Then we actually looked at the code, and first we compared the Quokka server that we're building, the one that's using SQL database, to the one that existed before, and we looked at how we had used these global devices and replaced those with database stuff using SQLalchemy. We looked at the actual endpoints, that would be the functions that implement these URLs that get called, and we saw that the get and the put are pretty much similar in the new version, except we replaced modifying the actual data that was in dictionaries to these API calls. And just jumping to that real quickly, we talked about how the APIs allowed us to isolate the code that was actually going out to the database, so that this API, we call the APIs, whether it's get all hosts or set host, the same thing for services and devices. We can call those functions and not have to change that when we swap out SQL database for Mongo database, etc. So we looked at the APIs. We did look at classes because we remembered that when you create an SQL database, not only do you need to define things, but everything is predefined. So your schema, your columns, your tables, etc., it's very structured and it's set in stone from the beginning. So you got to make sure you create these classes that identify all of the columns that you will be using. And in our case, that would be for device, host, and service. And we kind of finished up with, after we did talk about all of the initialization stuff that takes on that you see here, we talked about this thing which is created in order to circumvent issues with circular imports in Python. So hopefully you remembered all that stuff, didn't need me to remind you of it, and it's solid in your mind, and that you've learned how to use SQLalchemy to create database functionality for our Quokka application, our mini-quokka that we've created. Hopefully that's good and you understand it, and yeah, thanks for listening.